Welcome back. This topic that we're going to be covering in this video is an extension of our last topic, which was binomial probability. In the topic of binomial probability, I showed you how to find the probability of something happening x times during n trials. So an example of that might be the probability of 7 heads during 10 coin tosses. If you wanted to know that, you would use a formula that I showed you during that topic. But binomial expected value actually isn't a probability. So when you use this formula that I'm about to show you, you're not using this formula to find the probability of something happening. Instead, you're trying to find the most likely number of successes in a certain number of trials. So what this formula is used for is to find the outcome with the highest probability out of all possible outcomes. So like I said, you're not calculating a probability, you're finding the outcome that has the highest probability out of all possible outcomes. So, um, this formula would be used if you wanted to know let's say, the most likely number of heads during 10 coin tosses. So yeah, so this topic is related to the last topic, but it's not the same thing. And the formula for binomial expected value is this right here. EX is expected value. It's the expected value of X, which is just an event or an outcome, because the outcome will come out to some unknown number, and that's X. And so the expected value right here equals N times P, and N is the number of trials, and P is the probability of a success during each trial. So notice how N and P haven't changed since our last topic. They mean the same thing that they did in the topic of binomial probability. So let's just go over one example of binomial expected value, and you'll see that this is much shorter or a much more simple process compared to binomial probability. So let's say we want to know the most likely number of heads in 10 tosses of a fair coin. And when I say most likely number of heads, that's just another way of saying expected value. Because remember, expected value is the most likely outcome. So I could have phrased this differently. I could have said, what is the expected value of heads in 10 tosses of a fair coin? But I just use a different variation of the wording because it's good for you to be able to recognize slightly different ways of saying the same thing. So here we have expected value equals n times p. So remember, n is the number of trials, which in this case is 14 tosses, and p is the probability of a success during each trial. And remember, in each of these types of problems, the problem defines what's considered to be a success. So basically, whatever outcome the question asks about is defined as the success. So in this case, if it says what's the most likely number of heads, then you already know that, well, heads is what we consider to be a success in this problem. And um, so when you hear the word success in this topic, it's not a success like a good thing or a positive thing happening. Success really just means a specific outcome out of two possible outcomes, basically. One of them you call a success, the other one you call a failure. So remember, 14 trials, n is 14, and we have to know what's the probability of a success during each of these 14 tosses, during each trial? Well, we know we're considering a heads to be a success, and the probability of a heads is 0.5 during every coin toss. So in each of these 14 tosses, the probability of a head is 0.5. It's 0.5 during every coin toss. So P is 0.5. That's the probability of our success happening during each of the 14 trials, 0.5. So 14 times 0.5 equals 7, and we're done. So the most likely number of heads in 14 tosses is 7, which is half of 14. And I think if you think about it, I think it should make sense that it's 7 out of 14, because if the probability of a head during a toss is 0.5 and you toss a coin 14 times, it seems like it should be likely to get either half heads and half tails, or at least something close to that, right? So yeah, I think that this should be intuitive that this is the expected value. I'm just going to quickly share another example of a problem that I could have given you. So I could have said, what's the most likely number of boys in 20 childbirths? And then to get that, you would just, well, n would be 20 because it's 20 trials. And the probability of a boy during each of those births would be 0.5 because every time a child is born, there's a 0.5 probability of a boy, which means it would be 20 times 0.5, which would be 10. So the expected value would be 10. And that just means that in 20 childbirths, the most likely number of boys is 10 out of 20. And once again, that's just half, like it is here. And so just a few quick points to wrap up this topic. So remember that the binomial expected value isn't the outcome that'll definitely happen. It's just the outcome that's most likely. It's more likely to happen than any other possible outcome. So if you looked at the probabilities of all possible outcomes, this one would have the highest probability. And outcomes further from the expected value are less and less likely to happen. So in this situation that I have on the screen, outcomes further from 7 would be less and less likely. So when you toss a coin 14 times, 0 heads and 14 heads would be the least likely because they're the furthest from 7. And they're also the two most extreme outcomes out of all possibilities. And the last point I wanted to mention is that the actual outcome, or the outcome that's observed, is more likely to be close to the expected value in a large number of trials. So if one person tosses a coin 4 times and another person tosses a coin 100 times, the second person is more likely to get something close to the expected value of half heads because remember, larger samples tend to be more accurate. So if one person tosses a coin 4 times, their expected value is 2. And if a person tosses a coin 100 times, their expected value is 50 out of 100. But that second person is more likely to get something close to 50, their expected value, compared to the first person who's only tossing 4 times. The first person could easily get 4 heads out of 4 or 0 heads out of 4 because in a small number of trials, extreme outcomes are more likely to happen. So yeah, if you have any questions about this topic, just let me know.